Hey, and welcome back to your next video. We're moving on to solving by factoring. We've already been factoring in our last unit, so you should be pros at it by now. So now we're just going to take it one step further. So, what are we doing overall? What is the purpose of doing all of this solving by factoring and solving by graphing and any other methods we do? Well, we're trying to answer questions like this. A soccer ball is being kicked into the air. So visualize someone kicking a soccer ball into the air and the path that it takes. It looks like a parabola with a negative a value. So it looks like it's going up and then coming back down. So we can model that path that it's going to take by this equation. So the negative 16t squared plus 32t. And so the value of t is representing time, and then when you plug t in, you get a value for height, so how high it is over time. And you can find a lot of specific information based upon this. So you can find out how long it takes for it to reach the ground, how far away it's going to be, how high it's going to reach, how long it takes to reach the highest value, stuff like that. So let's think about graphing. So that's what it says underneath my face here. Let's think about solving by graphing and compare it to factoring. So if I were to graph the x squared plus 6x plus 8, you've learned this in the last couple lessons. So we would create a table of values starting with your vertex, count up, count down, and we would get this graph here. Now to identify the solutions, we look to where is it crossing the x-axis. So it's crossing here at -4 and here at -2. So the two solutions would be -4 and -2. So now let's try to do it in a different way by factoring. So if I gave you the equation x squared plus 6x plus 8, and I asked you to factor it, you'd say, okay, what multiplies to 8? That's going to add up to 6. You would tell me the values 4 and 2. Now this is very close to the -4 and -2. So let me show you what I'm going to do to get that answer. What I'm going to end up doing is taking the x plus 4, set it equal to 0, and the x plus 2 and setting that also equal to 0 and solving. So that when I subtract 4 from both sides or subtract 2, I get the two values of -4 and -2. And those answers are matching the graph. And it should, because we're solving just in a different way. So the reason that we're allowed to do that is something called the zero product property. It could be called something else, but in the big scheme, it's a zero product property. So using words, if the product of two quantities equals 0, at least one of the quantities has to be 0. So if you're multiplying two things to get 0, then either one of the numbers has to be 0 or both of them have to be 0. So you can look at in the middle of the chart here. So 3 times 0 is equal to 0, or 0 times 4 is equal to 0. So one or the other. Now, the way we're going to be using it is in the algebra terms here. If I have two things in here, in our case, it's going to be two binomials. Sometimes it's a monomial times a binomial, and it's equaling to 0, then one or the other has to be 0. So what we're trying to find are the values of x that's going to cause each of those expressions to be equal to 0, each of those binomials. So let's do a couple examples. This one here is already factored for you. So these two are already factored for our first example, which means we're just going to use straightforward zero product property. So if these two things are equaling to 0, that means where is y equal to 0, or where are your x-intercepts? That means both binomials or one or the other. So we're going to try to find where they're equal to 0. So let's start with setting each piece equal to 0. So 2x plus 3 equals 0, or 5x plus 7 equals 0. And then we're just going to solve for x like you did in the past. So solving equations, subtract 3, divide by 2, and we get -3 halves. For the one on the right, subtract 7 and divide by 5, so we get -7 fifths. So what we can do is write this as a solution set, just like this, with the braces around it like here, so -3 halves and -7 fifths. Now this is slightly different. You can see this first one out front here isn't a binomial, it's just a monomial. But we still do the same process. It's this times 2x plus 4. So either x has to equal 0, this piece here, or the 2x plus 4 is equal to 0. The x equals 0 is done. We don't have to do any solving there. Sometimes there might be a coefficient out front you have to divide by. But in this case, you don't. So then 2x plus 4, we subtract 4, divide by 2, and I get x is equal to -2. So this solution set is made up of 0, comma, -2. All right, so let's go ahead and actually do ones that involve solving. Now, if you look at these previous two cases here, it says equal to 0 and equal to 0. The zero product property only works if it says equal to 0, because we don't have a property for when it's equal to 8 or equal to an expression. So what we'll do is make it so it says equals 0, meaning let's move the 8 over to the other side. So I get x squared plus 2x minus 8 equals 0, and then we can factor. So what multiplies to -8? It's going to add up to 2, and the answer would be +4 and -2. Now, just like before, we're going to take each one and set them equal to 0. So x plus 4 equal to 0, and and y get x equals -4. Or we can take x minus 2 equal to 0, getting x is equal to 2. So these are the two solutions. Now, always check. It's always been a good idea to check your answer. Plug -4 back into here and here. -4 squared is 16, plus 2 times -4 is -8, giving us 16 minus 8. Does that equal to 8? Yes. Do the same thing with the 2. 2 squared is 4. 2 times -2, 2 times 2 is also 4, and then 4 plus 4 is 8. That's how we know that these solutions actually work. Same exact idea for the bottom one. So we want to get it so it says equal to 0 on the right. That gives us x squared minus x minus 30. So it multiplies to -30, adding to -1. The answer there, -6 and +5. So I'm going to take each one of those things and set them equal to 0 and solve. That gives us the two answers of 6 and -5. So we can write that as a solution set just like that. So we can write it as a solution set with the braces, or we can write it out as -5, 0 and 6, 0, because those are your two x-intercepts. So in summary, these are the steps you're going to do for factoring. Step number 1, write the equation in standard form. That means you're going to take all the terms and put them on one side of the equal sign, try to do it in descending order like we've been doing, and making sure that zero's on the other side. Step 2, factor completely. Take out your GCFs. You might have to do factoring by grouping, or you might have to do one of the other types of factoring we've done. And then finally, step 3, use that zero product property. So take each of those factors with the variables and set them equal to 0. Again, remember, there's sometimes it's going to be two binomials, or it could be a monomial with a binomial that you just factored out to the GCF. Finally, do not forget to check your solution. It's so important for you to check back in the original equation and make sure it all works out. Last example we're going to do with the 2 in front here. We're just going to factor it like we did in the past. Is it equal to 0? Yes, check. That means we can move on. So we multiply a times c to get -20, then -1 on the right. So what multiplies to -20 adds to -1? Some of you might need to do this whole chart. Some of you can probably find these numbers right off the bat, whatever you care to do. So I want to continue with the factoring by grouping. Unless you like to guess and check, you can do that as well. So this would factor, split up the -x into 4x minus 5x. As you can see, we're splitting that middle term right in half. And then I'm going to put the line down the middle. On the left, I'm going to factor out a 2x. On the right, I'm going to factor out a -5, leaving us with x plus 2 and 2x minus 5. So if this is equaling to 0, that means either x plus 2 is 0 or 2x minus 5 is 0. So we're going to find those two values where it happens. So for x plus 2 equals to 0, I'm going to subtract 2. For 2x minus 5, I'm going to add 5, divide by 2. You can leave it as 5 halves, or you can give me the decimal 2.5. Either or is fine with me. So instead of writing as a solution set, I'm going to write them as points. So I've got -2, 0, and 2.5, 0. Why am I saying equal to 0? Well, this is the same thing as saying equaling to y, and I'm substituting y with 0. These are our two x-intercepts, where it crosses the x-axis, and y is equal to 0. So what I'd like for you to do is take a look at the problem here, the -16t squared plus 32t, and try to see if you can come up with an answer for next block. All right, make sure you've gone back and take any notes that you might have missed, and I'll see you next block.